Hi there. Previously, we learned that we can define an object with object literal syntax. Essentially, we have a variable name, the name of the object, which is equal to one or more key value pairs. These are wrapped in curly braces. To extract information from the object, we can use either dot notation or bracket notation. With dot notation, we'll take the object name and attach the key name at the end. And we are returning the value, also called value, of that key called property. Dot notation is cleaner and usually preferred, but at times you will need to use bracket notation. Take a look. Oops. We can't access the value of obnoxious property with dot notation since it is a string with a space inside of it. We can get this value with bracket notation though. With bracket notation, we are returning obnoxious property, which is a function that does stuff. On the other hand, you can't use variables in dot notation. Here we have a variable. We'll try to access it first with dot notation and then with bracket notation. When we look in the console, we see that my object.variable returned undefined. With dot notation, it's looking for a key called variable, which doesn't exist. When we use bracket notation, my object with variable in brackets is essentially the same as saying my object with property, this string that is the value of our variable. This time, the program looks for this value and it finds property and returns the value. Objects can be a way to organize your code by grouping related items. Here I have a game of tic-tac-toe. I have two players and each of them has a marker. I can use an object literal to group related items. I've created an object, player1, with a player's name and marker, Tim and X. If you'd like, you can pause and create an object literal for player2. All right, if hopefully you just took a look here at player1 and were able to translate that to player2. We have Jen as our player and their marker is, oh, the difference between example 1 and example 2 is just a few lines of code, and so it doesn't seem like it's making a big difference. But we actually gain some special powers when we use objects to organize our code. In this case, since we know we have multiple players, we can write a function to return properties for each player, instead of needing to remember all of the variables from the first example. With a two-person game, it isn't so bad, but what if we had a game with 4, 8, 10, 100 players? The beauty of objects is we can write reusable functions like this to access data. I can call print name for player1, and I'll return Tim. I can use print name with player2 as the parameter. And this time we get Jen. Nice. Another thing to consider is that we might not know which player's name we want to print. For example, we might have a function that prints a message about the winner at the end of the game. Presumably, we don't know this when we start the game. Here we have a function called game over. It takes winning player as a parameter. Winning player may derive from another function with a conditional for whichever player reaches the high score first. For example, I have a function called keep score. Inside, I've got a conditional. If player 1 has a score greater than or equal to 10, we'll invoke the game over function with player 1 as the parameter. Otherwise, if player 2's scores is greater than or equal to 10, we'll invoke game over with player 2 as the parameter. For convenience, I can add score properties to each of my player objects in order to call keep score and in turn game over. And we see that Tim is the winner. Yay! If we have a specific type of object we need to duplicate, like players in a game, a convenient way to create them is using an object constructor, which looks like this. This dot property will be the key, and the parameters that we pass in will be the corresponding values when we create a new object. And new is an important keyword, actually. We can call the constructor function or instantiate a new object, player, by declaring a variable and using new player and passing in our parameters. We can console log the entire object or just particular properties of that object. Here we're logging the name that we just passed in to the player we created. Remember at the beginning of this scrim, we had my object, which had the key obnoxious property that was set equal to a function? We can do that here as well. With this dot say name, we can define a function that will log name to the console. Here I've created one player object with the syntax we just went over. Here's a challenge for you. Pause the screencast and create another player object, which will include a name and a tic-tac-toe marker as parameters. All right, I'm going to change player to be player one, and then I'm going to create another player named Stephanie, and her marker, of course, will be O. Now I can take my first object, player one, and I can chain this say name function. When I run this, we log Steve to the console. I can do the same with player two, and I'll run. We've logged Steve and Stephanie. All right, let's look at objects from another angle. Every object in JavaScript has a prototype. Basically, a prototype is another object that the original object inherits from. The object has access to the prototype's methods and properties. When using constructors to make objects, it's best to define functions on the prototype of the object, like we've done here. This way, a single instance of each function will be shared between every student object that we create. If I create a student, I can chain these functions to my new object, and we're going to log this name to the console. So instead of declaring the function inside of our constructor as we did before, we define it on the prototype so it isn't duplicated every time a new student is created. This would take up lots of memory and make each object larger than it needs to be. Why don't you get your hands on the keyboard and create a new student object the way I did here, and then call one of the that we've defined on the student prototype and chain it to your new student object. Hopefully that worked out well. So this time I can create another student. We'll call student 2. I'll declare a new student. I'll name him Mario, grade 8. And this time I'm going to chain the go to prom method to student 2. And when I run this, go to prom? All right. The recommended way of setting a prototype of an object is with object.create. This will return a new object with the specified prototype in parentheses. We can use a constructor to give the object additional properties. Let's look at the following code. We have an object called student. The constructor is actually empty this time. Even still, we can define a function on the student prototype called sayName, which will log the student's name to the console. We have a different object, 8th grader, which does have key value pairs in the constructor. We want 8th grader to inherit the prototype of student. So we have 8th grader.prototype. We'll set this equal to object.create with our student prototype in parentheses. Note, this is how we want to set the prototype, and not this way. This will set the 8th grader prototype to the student prototype, not a copy, and this can cause problems later if you try to edit something. For example, what if we later create a 9th grader prototype and we also set this equal to the student prototype? Then we want to define a method on the 9th grader prototype that logs a mischievous message to the console. We can instantiate a new 9th grader, and we can chain this method, say name, and when we run this, it's fine. It logs ha 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 to the console. But now if we create an 8th grader object and we chain the say name method to our 8th grader object, we are expecting the say name function that we defined on the student prototype, which will log this name, Mary. But when we run it, we get a nasty surprise since we set the 9th grader prototype to the student prototype. Here's a challenge for you. Can you pause the screencast and fix this code? Take a moment and do that now. We'll walk through it together when we get back. All right, well, we have the hint right here, so we'll just take out this mistaken code. We'll uncomment our 8th grader prototype is equal to object.create with our student prototype inside. And here, where we've made the same mistake again, we want to set it equal to object.create with student prototype in parentheses. Now when I run our code again, we log ha 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 for student 1, our ninth grader, Josh, and we log Mary's name for our 8th grader object. All right, we've talked about objects, object constructors, prototypes, object.create. Feel free to watch this again and pause the screencast to play with the code to reinforce your learning. Happy coding!